Assalamu alaikum dear students. Today in the online class we started our chapter number 4. The name of the chapter is Structure of Molecules, and the structure of molecules, today we discuss the introduction about the chapter, why atoms they form chemical bond, that is the reasons that why there is a need for the formation of the chemical bond between atoms. And in order to explain these bonding, we have two concepts in the chemistry. The first concept is known as Valence Concept and the second concept is known as Orbital Concepts. These are the two main concepts which explain the reasons that why atoms they form chemical bonds. So we start our lecture with the definition of the molecule. The molecule is the stable species, and we can define the molecule that when two or more than two atoms combine chemically, they form a molecule. In this diagram we can see that one atom of oxygen and two atom of hydrogen, they combine chemically in a fixed proportion by mass, and you can see that we have a molecule, and this is a water molecule. The chemical formula for water molecule will be H2O. The attractive forces which are responsible for binding of the atoms together, that type of attractive force is very important, and these attractive forces, they are known as chemical bonds. So the chemical bond, they can be defined that the attractive forces which keeps the atoms together in a substance is known as chemical bond. So this is the definition for the chemical bond. Now we discuss that why atoms form chemical bond. So the only reason that why the atoms they form chemical bond is because of the stabilities. They want to complete their outermost orbit. So in order to be stable, in order to gain stability, atoms they come close to each other and they form chemical bonds. Now the reasons that how the atoms, or the explanation that how the atoms they gain stability is explained with the help of two concepts, and the first concept is known as Valence Concept. Now the Valence Concept was given by two chemists, G. N. Lewis and W. Kossel in 1916. What is that concept? In a chemical bond formation, atoms take part by losing, gaining or sharing of electrons so as to attain the inert or noble gas electronic configuration. Now there are two main aspects of this concept, that is the atoms they lose electron, they gain electron, or they share electron. This is due to the stability of an atom, that is they become stable if they attain the electronic configuration of the noble gases. For example, in the case of hydrogen, we can see that the atomic number of hydrogen is 1. If hydrogen gain 1 electron, it will gain the electronic configuration of helium. We know very well that the atomic number of helium is 2. So hydrogen will gain stability if it gain electron. Similarly, in the definition we can see that by losing electron, an atom can also gain stability. In the case of sodium, the atomic number of sodium is 11. By the loss of 1 electron, the number of electron of the sodium will equal to the 10, and the atomic number of neon is 10. So by the loss of electron from the sodium, sodium can attain the electronic configuration of neon. So the Lewis concept was that by the losing, gaining or sharing of electron, all the atoms they want to attain the inert gas electronic configuration. So this is all about the Valence concept. So the Valence concept is that an atom have 2 or 8 electron in their outermost shell to be stable. For stability, we have two conditions, that is condition number 1 is that the atom may have 2 electron in the outermost shell, or an atom may have 8 electron in the outermost shell. So the atoms the outermost orbit of the atoms are incomplete, they want to complete it. So for the completion of the outermost orbit, an atom may have 2 electrons in the outermost orbit, or they may have 8 electrons in the outermost shell to attain the stability. We know very well, we discussed earlier, that atoms form chemical bond because of stability. Now what is stability? Stability means that atom complete its outermost shell with the help of 2 electrons or 8 electrons. Now valence concept is divided into 2 conditions, 2 rules. The first rule is known as Octet Rule or Octet Theory of Valence or Rule of 8. Now what is this? The tendency of an atom to attain 8 electrons in the outermost shell in order to attain stability. For example, in the case of oxygen, the atomic number of oxygen is 8. That is, its electronic structure will be K is equal to 2 and L is equal to 6. Now we can see that the outermost orbit, that is the L shell of oxygen atom, contains 6 electrons. If oxygen gain 2 electron, its outermost shell will contain 8 electron. Now that 8 electron is the keyword. That is, you can see that in the definition we use the 8 electron. So you will notice that oxygen will follow the octet rule because it gained the stability with the help of 8 electron in the outermost orbit. So octet rule, octet theory or rule of 8 may be defined as the tendency of an atom to attain 8 electrons. In the case of oxygen, we can see that the outermost orbit, that the valence shell contain 8 electron. And why they contain 8 electron? Because they want to stabilize itself, because they want to gain stability. Now after that we have the structure of sodium atom. You can see that this is the first shell, this is the nucleus of an atom. The central part of an atom is known as nucleus. The first shell is known as K shell. You can see that the K shell contains 2 electrons. So this is the K shell. After that we have L shell. L shell contains 8 electrons. Similarly, we can see that the last valence shell, that is K, L, and this is the M shell. Now you can see that the M shell contains only 1 electron. By the loss of that electron, that is, if we remove 1 electron from the M shell, the outermost orbit will be L. Now L shell contains 8 electrons. So we can see that sodium will follow the octet rule. Why octet rule? Because sodium gains the stability with the help of 8 electron in the outermost orbit. That 1 electron which is present in the M shell will be removed. For that reason, the sodium can gain the stability with the help of 8 electron in its outermost orbit, and now the outermost orbit will be L, not M. So sodium will follow the octet rule. Similarly, we have another rule. That rule is known as duplet rule or rule of 2. The tendency of an atom to have 2 electrons in its valence or outermost orbit in order to attain stability. Now the key word over here is 2 electron. For example, in the case of hydrogen, the atomic number of hydrogen is 1. Electronic structure will be K is equal to 1. If hydrogen gain 1 electron, the number of electron in the K shell of hydrogen will be 2. Now you can observe that the K shell of hydrogen contain only 1 electron, but if hydrogen gain 1 electron, the electron in the outermost orbit will be 2. With the help of the diagram, we can explain this. This is the structure of hydrogen atom. We can see that this is the nucleus of the hydrogen atom. The 1 electron which is present in the K shell, this is the K shell. Okay, so if hydrogen gain one electron from any other source. Okay, so this is one electron of hydrogen, and this is the electron which is gained by hydrogen. So the K shell complete itself with the help of two electron in the case of hydrogen. So we can see that hydrogen is an atom which will follow the duplet rule. Duplet means that the two electron in the outermost orbit. This is the K shell. We know very well that the K shell can accommodate only two electrons. So hydrogen has its own one electron, but hydrogen will gain one electron to complete its K shell. For that reason, we can see that hydrogen is gaining the stability with the help of two electrons. So in this case, we will notice that hydrogen will follow the duplet rule. The last concept which explains the stability of the atom is known as orbital concept. The orbital concept is the concept in which the atomic orbital, they combine with one another and give you molecular orbital. This molecular orbital will result in the formation of the molecule. So this is the orbital concept. Orbital, we have atomic orbitals, that is s, p, d and f. But keep it in your mind that s, p, d atomic orbital, they combine with one another and give us molecular orbital. This molecular orbital will result in the formation of the molecule. Now we have different types of molecular orbital. We can see, you will notice that this is the structure for s orbital, which is spherical in nature. The s orbitals, they overlap with one another and give us a bond which is known as sigma bond. So when the orbital, they overlap with one another in such a way that their end to end overlap with one another, like that. So that overlapping will result in the formation of sigma bond. So when there is a mixing of the electrons, so when there is a sharing of electron between the two atoms which overlap with one another end to end, that end to end overlapping of the atomic orbital will give us the sigma bonding. So this is the molecular orbital. The red color indicate you the formation of the molecular orbital. These are two atomic orbitals, but these two atomic orbital, when they overlap with each other, and if this overlapping is end to end, so that end to end overlapping will result in the formation of a special type of bond which is known as sigma bonding. So orbital concept explain the formation of two types of bond. One is known as sigma bond. How sigma bond is formed? It is formed by the overlapping of atomic orbital end to end. One end of the atomic orbital, second end of the atomic orbital, they overlap on each other. So that type of overlapping will result in the formation of sigma bonding. After that, we have another important overlapping, and that important overlapping is side to side. Now you can see that this is the end-to-end overlapping, but that p orbital, that is, we know very well that p orbital, they are dumbbell shaped. If the overlapping of the atomic orbital is side to side, now this is one side of the orbital, this is another side of the orbital. Now if that overlapping, if the overlapping is side to side, just like that, such types of overlapping will result in the formation of another type of bonding, and that type of bonding is known as pi bond. So in this diagram you will notice that the green color indicate you the formation of sigma bonding, and the pi bond is indicated in the blue color, that is the green color indicate you the formation of sigma bonding, but the blue color indicate you the formation of pi bond. So the orbital concept explain us the formation of two types of bonding, that is sigma bond and pi bond. So that's all for today. Thank you.